Hello everyone. In this presentation, we will discuss combined problems of UV, IR and NMR spectroscopy. I have posted several videos about the problems of only NMR spectroscopy. There are many kind of problems in NMR. Certain problems in which molecular formula is given with the calculation of double bond equivalent. It is little bit easy to solve that kind of problems. One more type in which percentage proportion of elements are given and later on we can derive the molecular formula with the help of empirical formula. One more type of problems in which square value is given. Square value indicates the proton ratio. So from that we can calculate the number of protons for different signals. So I advise that if you haven't seen those videos, then before watching this video, you should watch those videos. But in this presentation, we will discuss the combined problems of UV, IR and NMR spectroscopy. To deal this or to solve these kind of problems with your question paper, you will be given spectral data about of UV, IR and NMR in almost all the universities. So with the help of that, you can solve this kind of problem. Before we start, one more thing I want to tell you is normally whenever you solve the problems of UV spectroscopy, students calculate lambda maximum. But in the combined problems, you are not going to identify or calculate lambda maximum. On the contrary, you will be given lambda maximum and just in a couple of sentences you have to analyze that. So there are few statements you should understand. Sometimes this data is given that compound is transparent over 200 to 220 nanometer or in the range of this. So this statement actually indicates the absence of conjugation. Now absence of conjugation, it doesn't mean that absence of double bond. Double bond can be present, but you know that conjugation means alternative double bonds. So transparent over 200 or 210 or 220 nanometer, if this kind of data is given in the problem in the UV, then one should understand that conjugation or conjugated dyne system is absent. There can be single double bond present in the compound. Second thing, sometimes intensity, we use the epsilon unit, so that is also given. Now epsilon value in the range of 100 to 1000, that is indicating presence of N to pi star transition, and normally N to pi star transition is possible into the carbonyl compounds, particularly those compounds in which C double bond O bond is present. And epsilon value beyond this 100 to 1000 and nearly up to 10,000, that is indicating pi to pi star transition. Sometimes instead of epsilon value, log epsilon is also given. Now we can understand that the logarithm of 100 is 2 and logarithm of 1000 is 3. So log epsilon value in the range of 2 to 3 is obviously indicating the N to pi star transition, and 10,000, so logarithm of 10,000 is 4, so that is indicating pi to pi star transition. So keeping this thing in mind, that now let us solve the first example. Molecular weight given here 148. This particular example is 3 to 4 times asked in the examination of Gujarat University. See, UV is given 254 nanometer, epsilon is 200 nanometer, IR there are 4 bands, 3015, 1825, 1785 and 1602 centimeter inverse. and only one signal in NMR, that is 7.25 delta complex. Now friends, it is not important that how many problems you solve, but the important thing is how you solve. And read the problem, and before you start solving the problem, you must get the immediate information in your mind. That is very, very important. So first thing is UV, you can see that epsilon value is at 200. So 200, so that is already I told you that it is in the range of 100 to 1000. So that is indicating N to pi star transition. And N to pi star transition, so most probably some functional group that having carbonyl part C double bond O, uh, not particular IR, but NMR is important, 7.25 delta. So we know that delta is indicating the presence of aromatic nucleus, and also sometimes it can be given complex or singlet, or in the case of di-substituted benzene ring, doublet of doublet can also be given. So immediate information we are getting is this compound is aromatic. And one more thing from the NMR, we can say that only one signal that is indicating that all the protons must be equivalent protons, because the signal, there is only one signal given in the data. And one more thing which I told you, that epsilon value in UV, that is indicating presence of C double bond O group. Now this part we have discussed. IR 3015 is actually indicating the presence of aromatic stretching, and that is also supported by the delta value of the protons. Very important two IR values, 1825 sharp and 1785 sharp. These two collectively indicates presence of N-hydride group, and N-hydride is this portion. Now you can see that this CO group, so that is also supported by UV. So CO twice and one oxygen, this is the general formula of the anhydride group. So particular molecular weight of this portion is 72, and 1602, that is also indicating the carbon double bond carbon aromatic. And already we have discussed this thing, NMR only one signal, and 7.15 delta indicates aromatic ring. Now whatever we have identified, so molecular weight of that portion we will subtract from the given molecular weight of the compound. So here you can see that 148 molecular weight minus 72 anhydride group that we have determined from the two IR bands, 76 left, and 76 is molecular weight of di-substituted benzene ring C6H4. There are no more protons because there is only one signal. So in the compound there is anhydride group and di-substituted benzene ring. There is no more protons because in signal protons are not mentioned. So compound should have following structure, this, and this compound is called phthalic anhydride. Now you can see that this is your C6H4. These two hydrogens are displaced by anhydride group. So all these four protons, aromatic protons, that's why 7.15 delta, only one signal because all the four protons complex. Normally we consider the all protons of benzene rings same. This is anhydride group supported by IR value, and 200 epsilon value in UV also supported this CO group. So this is the way you should solve the combined problems of UV, IR and NMR. I will also post some more videos of some more problems later on.